this is a recording to show you the setup for the experiment for Component 3 BTEC Tech Award in Engineering. You're going to be provided with apparatus to allow you to conduct an experiment, and you then have a demonstration by your teacher, which is what I'm about to do now, followed by you conducting the experiment, the practical activity, up to 45 minutes. When your teacher is doing your demonstration, you can make notes that you can use in your own practical activities, and that can be up to 2 sides of A4 paper when you're making your own notes. What your teacher is not allowed to do is to interpret the results for you. So I'm going to do here, I'm going to show you how to set up the experiment. Because this is preparing for some remote learning for Year 11s, I'm actually then going to conduct the experiment immediately afterwards and record a data set. It's worth noting I've actually done this experiment twice before to look at the results that I get, and when you are doing your experiment, it's important that you know that you should adapt it or change it to make it work for you as the person carrying out the experiment. So I'm showing you the method of using the apparatus, I'm showing you what equipment that you use, I'm giving you an example data set, but if you are conducting that experiment yourself, you can conduct it using different measurements and recording possibly a different set of results. So the only reason that I'm going to be doing that in a minute is for people that don't have access to this equipment in preparation for their mock exams or whatever. Okay, so the equipment that you're provided with is some sort of back panel, a paper angle measuring template, and 2 rulers. You're also going to be given a single mass of 100 grams. In this case, it's incorporated into the mass hanger, and some sort of bracket for holding it onto the rulers. And you're going to need 2 clips, 2 stationary clips, which you'll see in a second. So your starting point, you're going to conduct the experiment twice. The first set of data is carried out with a single ruler. You then repeat your experiment using a second ruler to give you double the thickness. Okay, so I'm going to conduct this experiment by clipping on my ruler, and I'm going to clip it, making sure that it's held in position accurately. Now I'm going to be measuring from this ruler, so I'm actually I'm looking at where my ruler comes to on that bracket and making sure that it's sitting on, in my case, a 4 centimeters. That becomes my kind of 0, my datum to take other measurements from. I then slide my mass hanger bracket onto it and hang the mass hanger on it. Okay, now I'm conscious of the bright light. This is so that you can see what's happening. That does cast a lot of shadows, so I apologise for that. I couldn't really find a better way of doing it, so hopefully you can see the measurement at this point. So that would be 0. Now at the moment that's not showing me any deflection. I'm not going to record 0 as my first measurement. So what I'm actually going to do is I'm going to measure from that point a series of distances. The second clip is used to prevent the mass hanger from sliding off whilst you're taking your measurements. Okay, so that allows you to position it and be quite accurate with it. As I said, I did this experiment a couple of times, and one of the reasons was that on my apparatus the mass hanger was hitting the foot or hitting something I'd put under it. So you might want to just make sure that your equipment isn't going to, they call it fouling. If it's going to knock against something else, you might want to just double check that it's not going to do that, even if it's bending at its maximum. All right, so I did a bit of checking of that. So your method is to move your mass hanger a series of intervals, taking a measurement of the distance along the ruler that you're coming, so the distance from 0, and also the amount of angle that it changes at this point, which we call the angle of deflection. Okay, the amount of deflection. Now this is your experiment, so you conduct it in the way that you see fit. But that's basically the end of the demonstration of the setup and use of the equipment. The only extra bit that I'm going to show you now is that, if you're only watching this bit, is that once you've completed it with a single ruler, you unclip it and position your two rulers together, making sure they're lined up, and clip those into position, ready for the next stage of your experiment that you conduct in exactly the same way. Okay, so that's the only change. Once you've got your method right, the only change is that you clip a second ruler on top of the first, and then you repeat your experiment. Okay, so what I'm going to do now is I'm going to actually conduct that experiment. So if you're doing this in class and you're going to do your own experiment, this is where you go off and you do your own experiment based on that information. If you're someone who's working remotely this year, or with you just want to have a refresher if you've already done this in class, I'm now going to conduct the experiment and record a data set from that. Okay. Right, so let's conduct that experiment. Okay, so here we go. Experiment number 1, with a single ruler, a 100 gram mass on a mass hanger, and the first measurement, I'm going to come along 30 mil. And my 30 mil is my distance, and my angle of deflection, if I look at it here, is 1.5 degrees. Okay, my second measurement now, I'm going to come along a further 3. I'm going to put this clip on now and release it. Let it stop moving for a minute. And that's giving me a deflection at 60 millimeters of 4 degrees. I'm now going to slide it along again. Try to make sure everything's as steady as possible. And that's giving me a deflection of, I'm going to say 8 degrees, 7 degrees, 60, so that's at 90 millimeters. And then I'm going to come a further 30, and this is going to show me at 120 millimeters. I've now got a deflection of 12 degrees. I'm going to come a further 3. Okay, so this is at 150 millimeters. I'm getting a deflection of 16 degrees. Now we're going to come a further 3. Okay. That one is 180 millimeters, and that's given me a measurement of 20 degrees. So I've done 1, 2, 3, 4, 5, 6. I've got 2 more measurements to take. So I'm going to come a further 30. Just check that I'm sitting in the right position. You want to make sure that your measurements are correct angle. Okay, that one's coming down to 10, 20, that's 24 degrees. And that was at 210 millimeters. And then my final, my 8th measurement, just release that slowly. Okay, my 8th measurement is 10, 20, I think we're on 27 degrees. And that was at 230. Gives me 27 degrees. Okay, so I'll just show you those numbers in case you were struggling to follow that. I've now completed my first 8 measurements, and those are sitting there with a single ruler. So now what I'm going to do is I'm going to repeat that experiment with a double ruler, and we'll see what we get. Okay. Okay, so I've now got 2 rulers in position, and I'm going to put my mass hanger bracket on it. My 0 is on the 4 centimeters on my ruler again, and then I'm going to measure 3 centimeter, 30 millimeter increments from that. Okay, so at 30 mil, so we're sitting at 0 there. I'm going to just clip this bracket on just to help hold those 2 rulers together. At 30 mil, I think we have a deflection of 0. If I come a further 30, so we have 0 degrees, and then we have 1 degree. I think I'm going to read that as 1 degree. So I'm just writing my data down as I do this experiment. And come a further 30 mil. Just move my clip up. Okay, that deflection there, 2 degrees. So at 90 mil, that's 2 degrees. Then we're coming a further 30. My deflection there is 4 degrees. That was at 120 millimeters. Further 30. Ooh, 6.5, 7, 6.5. So 150 gives me 6. Yeah, I'm going to say it's 6. I'm trying to read this at the same position each time. I could look under and over the rule and all sorts of stuff, but I'm trying to stay in the same position each time I read it, because otherwise I'll get some false results. Further 30. Okay, so 5, 6, 7, 8. From where I'm standing, that's 9 degrees, sorry. So 180. That's giving me 9 degrees. Okay, try not to let it swing too much. So this one is at 210, and the end result of that is 510. I think I'm at I'm going to record that as 10. If I hold myself in the same position, it's 10.5. 10.5, and then my final measurement at 230 millimeters. Okay, so again, I'm making sure that I'm not bouncing there, trying to stop it from swinging a little bit. Okay, and I'm now coming down 12.5. Could read that as 13, depending on the angle that I'm standing at. 12.5, 13. So there we go. I've got two sets of data now, and that's shown me quite clearly that there's a difference between the two. I'm going to just hold that data set up for you to have a look at there. Hopefully you can see that on the camera. Obviously you need to have recorded that on your proper documentation, and that practical task should have taken you 45 minutes. Now, I've done this before. It takes me about 10 minutes to do that. So if you think about that, by the time you've recorded your results and you've maybe gone, actually that experiment isn't working out brilliantly, I'm going to repeat that. If you weren't sure on your data set, you have time to repeat that experiment. Okay, and what we'll do in class, because this is a mock, this is preparation, we'll do some talking through that and looking at how you get your results and interpret them. But for now, that's our data set. That's our method of conducting the experiment. You do it once with a single ruler, second time with a double ruler. Okay, so I hope that's gone okay for you. Hope that's useful.